Crazy as it may sound, rocket ships, the technology that epitomizes future exploration, seem outdated. How is it that rockets have been around since 1942, yet other methods of space travel that don't emit tons of greenhouse gases or risk the safety of the passengers still haven't been created? Fortunately, there are projects in the works for the development of a safer and cleaner way of getting to space. Originally based on concepts conceived in science fiction novels, the space elevator has become a promising next step in the future of space travel. The space elevator would effectively be the tallest structure on Earth, consisting of a sort of space station attached to the Earth by a tether. In order to ensure it does not fall out of Earth's orbit or crash into the Earth, it would have to be put into geostationary orbit, meaning it would revolve around the Earth at the same rate that the Earth spins. To best accomplish this effect, the Earth's tether would need to have a base on the equator so it can remain at a stationary spot in space relative to the Earth. Take a satellite, for example. There are many geostationary satellites, which hover over the equator, and there are some geosynchronous satellites, which hover some degree above or below the equator. While both complete a full orbit in a day, only the geostationary satellite will be able to hover above the same spot for the entire time, because it follows the same axis of rotation as the Earth. To ensure the top of the elevator doesn't end up at a different place than the bottom, the elevator must be put into geostationary orbit. Following the principle of orbiting, the centrifugal force, or the force drawing the elevator away from the Earth, would need to equal the Earth's gravitational force, or the force drawing it into the Earth. The radius of this orbit from the surface of the Earth would therefore be about 36,000 kilometers. There would need to be a counterweight on the other side of the station as well, which could be anything from another tether rope to a captured asteroid even, that would put the center of mass more than 36,000 kilometers from the surface of the Earth, ensuring the tether is pulled taut. The material of the tether poses many challenges in the creation of the elevator. However, a promising solution in carbon nanotubes, which are extremely strong, thin, and flexible, is being explored. While current nanotechnology only allows these nanotubes to be built at an extremely slow rate, scientists around the world are working towards creating these ropes. If a space elevator were to be created, the cost of sending cargo to space would decrease by 95% and be vastly safer for the passenger than rockets. Plus, though it would take a lot of electricity to make the elevator climb, the elevator could be powered by solar panels on the top of it. This would mean the satellites could be sent to space easily and at little environmental or financial expense. It has even been theorized that if the counterweight were to be made of another carbon nanotube, then, since the far end would be going at such a high velocity, it could be used to slingshot something to Mars. A topic straight out of science fiction, literally, has come to be a feasible solution to current problems and has illuminated the future of space exploration. As technology continues to advance and scientists look for more efficient ways of doing things, out-of-the-box thinking might just take you out of this world.